help. They love that.
Okay, should we go ahead and get started? All right, so this is the class on vermicomposting. My name is Amy Schuster, and I'm an organic gardener, and I've been doing vermicomposting professionally for about 10 years. I'm originally from the Midwest. I'm from Wisconsin. I've been down here in Georgia now about 5 years, but I first learned to vermicompost at an urban farm that you might have heard about if you're getting into vermicomposting. It's become very well known. It's called Growing Power. And what Growing Power is, it's an urban greenhouse farm establishment. I think it's 2 to 3 acres right in the city. And what the development there, the gentleman who runs that place, his name is Will Allen, and he's been to the Georgia Organics Conferences, and if any of you spend any time in the Midwest, I would definitely recommend checking them out. But what they do is they collect a lot of food waste from around the cities, food that doesn't get used from the grocery stores. They use the coffee grounds and then also brewery waste from Milwaukee. And they take that and they use composting worms to create soil to grow in so they can bring that soil to city lots, regardless of what the history has been, and grow safe and healthy food. So I worked there for several years, and then all my family moved here, and I followed them. And I got a job right away working for one of the Barrier Island resorts. It's called Little St. Island. So where we are located is if you go about an hour south of Savannah to Brunswick, and then over a bridge, go to the very north end of St. Simons and get on a boat. And Little St. Simons is actually one of the youngest islands of the Barrier Islands for coastal Georgia. So all you guys know that means that we have the youngest soils. And so when I got the job to grow the garden there, I figured, well, okay, we wanted to do it certified organic, and the space had already been certified when I came on to the project. And I thought, okay, well, what I do know about growing, and I'd work on several farms around the country at that point, but nothing in sandy soil conditions. And I thought, well, okay, if you don't have soil to grow in, make your own. And so, and then that really matched another issue that we were dealing with, being that the company is really striving to manage itself ecologically and sustainably. We had all this food waste from our restaurant facility, and the two choices were to haul it off the island on a boat and then pay for the trucking for it to be hauled to a dump where it's managed the way it is at a dump, or feed it to our local wildlife, which wasn't a good choice for us either. So starting our vermicomposting systems on the island was twofold. Provided us some organic matter to build our gardens upon, and then it also diverted waste. So that's a little bit about my background, and my experience has been 100% working with vegetable waste. So there are tons of people around the country that have amazing projects doing large-scale animal waste composting, and I can certainly direct you to some great resources, but that's not been my experience. So I'm going to speak mostly from what I've learned at conferences and classes and the self-study of having done this with food waste for about 10 years. And please ask questions, and this is for you, so whatever you're here to learn. How many people in the room have done some vermicomposting? Attempted? Okay. Yeah, okay. And okay, and in the Midwest too, we would hold classes like this, and then people would go home and be very excited. And I did bring some worms for people that might want to buy some worms today and go home and get excited. I know that is when you come to a class and you want to just get started. In the Midwest, typically, they take them home, and we'd hear from them from a month later, and the worms had frozen. So we don't have that issue here. Our issue and our challenge in doing vermicomposting is the summer heat. So now is actually a really great time to get started. The next great time, if you get sidetracked with other projects, just time frame wise, I wouldn't start a new vermicomposting system until the fall once it cools down, unless you can do it indoors. I've only ever done it outdoors. Not true. In college, I had a Rubbermaid bin in my bathtub indoors in Wisconsin. So you're going to learn throughout the presentation that temperature is really important, and being able to control moisture is really important. So those are some of our issues with doing it in the South. So these are our worms. And I'm going to pass around as we get moving forward. I've got one container here of our castings that we produce on Little St. Simons Island. And this is really the foundation for our soil building. And then one container hiding under some paper here, because one thing we know about worms is they don't like the light. So you go ahead and meet the worms if you'd like to. Dig down in there, and there's a lot in there. So we're going to just talk a little bit, starting out with the biology of the worms and how are these earthworms different than maybe the worms that you're finding in your garden, and why are they appropriate for this type of composting. And then we're going to get to the how-tos of how to do this at home. So vermicomposting, using earthworms and microorganisms to convert organic waste into a nutrient-rich humus fertilizer amendment. So this slide, unfortunately, it's not very clear, but what I'm trying to use with this slide is to recognize, because I think I was doing this for about 5 years before it really settled in, because I would harvest these things, and if I couldn't sell them at the market or to the restaurants, I'd get so excited to think about wanting to feed it to my worms, or my fresh banana peel, like I gotta get that in my worm bin, because those worms are gonna love it, you know, my fresh organic lettuce leaves, they're gonna love it, and I had all these visions of them just being as happy as I am, eating these fresh organic foods I was growing. But as we see here in the cycle of decomposition, right, we remember this, starting with the living plant matter, and then the leaf matter starts to decompose. And this is a picture of the decomposition process. And where it starts with is the bacteria and the fungi, right? And so then this is the primaries, the secondaries, and then in the end here, these are actually our earthworms. And so these guys are all feeding on that next layer above it. And so the worms in your compost bin aren't themselves eating your lettuce leaves and banana peels and coffee grounds. It's the bacteria that are breaking that food waste down and the microbes that they're feeding upon. Okay, so if any of you went to Herman's presentation this morning in the cafeteria, what's your question? I'm sorry, you're so patient.
Did you go back to the vermicomposting thing, or is it?
He kept taking some
Yeah,
notes.
because the mom wants us to take notes.
Okay, well we're gonna, you know what? We're going to answer questions as we can along the way, but since we only have an hour, then we're gonna maybe take more questions at the end, okay? But real quickly, vermicomposting is using worms and other microbes to turn organic waste back into fertilizer in soil and humus. Does that answer your question? You can ask me again afterwards. Okay, so what we know about composting is that we have two types of composting. And what Herman was talking about this morning in his presentation, if you were there, he's talking about hot composting, which is what a lot of us have done traditionally on our farms. And that's the thermophilic composting. So we know that when we put in our chicken manure and leaf matter and food waste, and we make our compost pile, the temperature spikes, and that's our goal in hot composting, because we want that temperature to burn out pathogens, to kill weed seeds. So that is our goal in hot composting, right? It's usually static pile composting or long windrows. I use one of my projects a 3-bin system, if anybody's heard of that, where you turn from one to the next. And what we spoke about in any composting class is the components of making composting happen is your nitrogen, which is your food waste, your carbon, which are usually considered your browns, like your leaf matter or old grass clippings. Those mix together, introducing oxygen and water, feed the microbes. The microbes do their job, eat ferociously, heats the compost pile up. That's what's making composting happen, is all those organisms in there. But because the pile is a vial, eventually the oxygen gets depleted, and you see your temperature drop, right? And then in a week or a month or however long it is, you got to turn it again, right, to get that temperature high, to continue with that process of hot composting. So it requires aeration. So what we're doing in vermicomposting, it's a mesophilic composting method. It's a cold composting method. So it's self-aerating because the worms are doing the turning, and the worms are very heat sensitive, and the microbes, there's certain microbes and bacteria that live at high temperatures and certain microbes and bacteria that live at low temperatures. So what a lot of farmers and professionals do is they'll actually have their hot composting systems going where they'll do an initial compost, and they'll add all those materials together, and they'll heat that material up for a certain period of time, and then either they'll move it, or the worms will move over, and the worms will essentially finish the job. But it's a way to combine those two systems, because a lot of people ask in their home composting system, because you don't want your worm box to be 120 degrees. The worms would be long gone. So a lot of people do find that they end up with weed seeds and things like that, and they wonder, how do I manage that? And so the way that you manage that is by doing hot composting first with your initial material, if that's your desire. Sometimes you're happy to have a cucumber sprout in your compost and you replant it and everything's good. But those are the two different methods of composting that I wanted to make clear right away, is the hot composting and the cold composting. So we'll get all into the needs of the worms, and you'll see why that is. But just in talking about castings, and I guess I'll put those around now. So I used to sell probably about a 1.5 pound bag in Chicago at the markets for about $20. This stuff in the industry is considered and called black gold because it is really that valuable. So you'll see this is from Little St. Simon's, and it's been partially sifted, so you'll see little pieces of envelope in there, and it's obviously not commercial grade, but it's what works for us. But go ahead and dig around, you can smell it, you can look at it, you're going to see that, excuse me, there's eggshells in there that haven't been processed out yet. But considering that my garden, the native soil in my garden is beach sand, being able to have this material on hand is tremendous. And we are at Little St. Simon's vermicomposting about 150 pounds of food waste a week from our kitchen. We serve breakfast, lunch, and dinner to 32 guests a night. And so it's really valuable. And so we're going to get into some of the science that's been done. But just in brief, vermicompost castings, which is what those are called, they hold available nutrients and moisture in the root zone of the plant. So in my sandy soils, having something to preserve around the root zone of my plant is tremendous. So what a lot of people will do is when they're planting out their transplants, they'll just sprinkle in maybe a 1/4 cup of castings or even less. But it sort of inoculates that root zone and is really beneficial. It increases plant productivity, increases yields. It provides plant growth regulator hormones. That's really significant, and that they're finding that the vermicompost is demonstrating more of these plant growth hormones, which is what sends the messages, the chemical messages to the plants on how quickly to grow, when to flower, when to fruit, all those messages. And this little note over on the other side, one of the most recent conferences I went to, one of the university professors was telling us that they found that these same plant growth hormones are only found in our old growth soils that have been built up for eons, and vermicompost castings. You're not finding them anywhere else. So that's pretty interesting. It also has microbial activity, depending, of course, on what your input is and what you're using to make it, but between 10 and 1,000 times higher than common compost. And then, of course, when we know that it's the biology in the soil that's feeding the plants, that's incredibly valuable information to know that your vermicompost can inoculate your soil, as I've said, and help feed your plants. And it has a much higher microbial diversity, and that has a lot to do with the temperatures and what lives at certain temperatures in our compost. So it improves seed germination, it improves tilth of the soil, and it has been known, and I'll tell you some research in a little bit, to help suppress some of the diseases that we're familiar with. The Pythium, you have to forgive me, I probably will mispronounce these, but the Varicillium, who's that, Rhizo, I don't know, you guys know maybe. And then I am mostly interested in its effects on plant parasitic nematodes. One of my garden projects has a tremendous infestation of root knot nematodes. And have anybody dealt with that in your gardens? It's real common in sandy soils of the south, and it's a huge challenge for growing. So there's been a lot of demonstration to show that these worm castings are really beneficial in suppressing root knot nematode, and if you have presence of root knot nematodes in your soil, that worm castings can help your plants survive beyond their infestation. Am I talking too fast?
No.
Okay.
Whoa.
Do you want to meet the worms now?
Disgusting.
Okay. What's that?
That's a worm protein.
Yeah. So check that out.
Australia.
That is one huge worm.
That is one huge worm. So write that down for your mom. She'll be really impressed. The giant Gippsland earthworm of Australia. It is the longest worm that we know about. It's 22 feet long. Earthworm.
Do we have them here?
No. No, I don't think we do. So there are 6,000 different species of earthworms, ranging from half an inch to 22 feet long. Yes, sir. What's your question?
Is it okay if we whole idea forms?
If you what?
Whole idea worms?
Yes, you can hold them. Thank you for asking.
Just don't squish them.
Don't squish them. No, no, no. They won't like that.
Y'all know that, James.
So these are the worms that we use here in temperate climates. These are the red wigglers. Icena fetida is what they're
Could you
called.
skip back to the giant worm? I
Need that
need to
name?
write down the name.
Okay, there you go. So, a lot of people ask, because one of the things we're going to talk about is that these are not native creatures to our region. And a lot of people ask, why don't we use native worms? But from what I understand, and if there's any scientists in the room that can provide more information, I've been told that there aren't any native worms. Most of us have worms in our garden, and that has everything to do with us having over the centuries brought in planting material and introduced them. So you are probably going to find worms, and most of the visitors to my garden, especially longtime gardeners, they're like, I've been doing that forever, because they start composting, and once it gets cold enough, the worms show up. And they're of course going to do their job, just like we talked about earlier, and they will decompose. But this type of worm, the red wiggler, you got that? The red wiggler is actually best for this type of vermicomposting. So that's what we choose for this region.
Question?
Yes?
Are these the same worms that you see in bait shops?
Well, they can be, yeah. So I know people that have successfully started a new bin just going to the bait shop. And red wiggler is a really common name for the worms. The difference being, you can also order worms online. The difference being that the online worms that you're going to buy from a reputable vendor is already going to be a reproductive age, and they can guarantee that it's only one variety. Where a bait shop worm has not been grown likely for vermicomposting. So, and I forget what the rate is, but it ends up being, because you typically want to start a new system with about a pound of worms, it ends up not being, I guess, that much savings. I forget what the bait shops are selling them for, but
Like about $3.50
a little cup, right?
There's normally like 20 or 30 in there.
Oh, right, okay, so 1 pound of worms is 1,000 worms. So for $20, you're better off just ordering them online. I did hear somebody recently tell me that on Craigslist in Savannah, they found red wiggler composting worms, so.
If you have time though, you could do the little bucket. If you really attend them for a little while in the buckets,
Uh-huh.
then put them in your compost, they go a lot quicker.
Oh, yeah.
From my experience.
From the
And
bait
I'm
shop
not-
worms?
Yeah, and
Okay.
I'm very simplistic, I'm not a scientist.
Will it work for you?
It worked for me.
Yeah. Okay, so this is why we use this variety of the red wiggler worm. So they are epigeic, if I pronounced that right, means they're surface feeders. They live in the top few inches of the soil. Where some of our other earthworms that we see are really burrowers, and they go very deep into the soil. This type of worm lives just on the top. And so that's great for vermicomposting, because the way that we do it is we're constantly adding more and more material to the top of our systems, and they're always going to stay on the top. They're also ferocious eaters, reliable reproducers, and they are most adaptable to living in confinement, which is what you want to do when it's your livestock and you're depending on their work, because you want to keep them contained. And they're also small in size, not 22 feet long, although I would imagine that's a pretty tremendous casting. But they're also somewhat tolerant of temperature fluctuations. So, and I was at a conference recently with a bunch of people from tropical regions. There's a tropical variety that I wondered might be better for the humidity that we deal with here in the South. But I've been told by the specialists that this is what we want to stick with, this red wiggler for our region.
Could you go back to the red wiggler thing? I just started writing it down.
Okay, well, we'll just keep going on, but afterwards you can ask me any questions you still have, okay? So just make a note on your page, and we can talk about it again.
It tickled us.
We don't have a whole lot of time, so I want to make sure we get through everything. So, responsible stewardship, certainly recognizing that these are non-native species. And so on Little St. Simon's, being that it's something of a nature preserve, and our goal 100% of the time is to keep the island as undeveloped and pristine as it is, we were very cautious about bringing these creatures onto the island. I come from the Midwest, and I have this website down here. If anybody's interested in learning about some of the actual real negative impact that worms have had, this website will teach you more about some of the impact that the worms from the fishing industry has had. In the glaciated areas around the Midwest lakes, there were no native worms after the glaciers. And then we started introducing them, and being that they're the decomposers of the system, they started breaking down all that leaf matter in the hardwood forests in a rate that was much too fast for the forest to uptake that nutrition. So it ended up actually having some negative impact. An important thing that I think is to remember is the difference between just a non-native and an invasive species, and that has, from what I've learned, everything to do with habitat matching and whether or not you've invited something into your environment where its native environment is well enough matched that it can go out and live prosperously and spread itself. And we know plenty of those in Georgia, but the difference from Europe, where these worms are from, is that our soils are acidic, and they don't hold moisture very well. So the worms breathe through their skins, and they don't like acidic soils. And so everything that I've witnessed in our little project is that they're not getting into our area around the garden. The other thing about vermicomposting is if you want it to be working effectively is you're providing a food source. And being that they're ferocious eaters, they're going to want to stay where the food is. So the best thing you can do is just, if you're going to choose to do this, and you're in a really sensitive region for natural, ecosystems, is just to contain them really well. So I've seen some other really interesting ideas if anybody wants to talk more about that. But I like to just point out that we should be aware of the fact that these are not native species and could potentially have a negative impact. So a little bit on the red wiggler biology. They are cold-blooded. So the temperature of their body matches the temperature of the air, whatever that is. So if it's 32 degrees in Wisconsin, they're going to freeze. If it's 99 degrees in Georgia, they are way too hot to be reproducing and to be very happy. And so temperature is one of the most important things that you want to think about in creating a new vermicomposting system. They prefer temperatures between 59 and 77. They, of course, can live down to 33 degrees, and they can live higher. But I think that an important note for us in the South is humidity. So I've talked to growers raising the same worms in the same conditions I am, or the same methods that I am out in California where there's low humidity, and they say their worms are happy and reproductive all summer long. My worms are not reproductive all summer. They're going to stop reproducing by probably May and June, and then they're going to be sort of dormant through the summertime, and it is clockwork. Once the temperature cools down and they're a little bit happier in their environment, then they start eating more and reproducing more. So of course, if you can do this in a garage or somewhere else, and we're going to talk about a few different scales of doing this at home. So if you were able to do it in a bin similar to this, you could maybe bring it into your garage or into your house during the summertime and keep those temperatures consistently cool. And you can just use a tiny little thermometer, a little soil thermometer, or even a kitchen thermometer, and just stick it in your bin and just try to keep track of how warm it is. And we're going to get into some of the indicators. If your bin's not happy, you're going to know that.
I was
Yes,
just going to
ma'am.
mention that an igloo cooler works pretty well.
Oh, great. Okay. And you just drain or drill drainage holes into it? Perfect. Okay. And in terms of that as well, mentioning the igloo, I haven't experimented very much with it yet, but I have heard people, of course, in the Midwest where I'm from, you could insulate your pile with hay. Or be able to insulate it in some way by putting it underground. Down here, I've heard people talk about actually taking those freezer packs and wrapping them and putting them into their bins. Or what did you say?
An old freezer.
An old freezer? Sure. Yeah, and just make sure that dial's working. Oh, but turn it off, yeah. So there's definitely ways to work with your system to keep it active year-round here. Okay, so they have no eyes, no ears, or no lungs, so they breathe through their skins. So improper moisture can kill them really quickly, actually. And so that's a really important aspect, temperature, moisture. And then light will paralyze them. So that's why we have our worms covered up today. We don't want to harm them in the light. But you can also use light to your advantage then to keep them in your system. And I'll show you a picture later of a local worm farm that actually has lights around the outside of this farm. And in the winter, at night, it kind of looks like a baseball field out there. And he puts light on, and the worms don't want to come up into the light to leave. So they also like a pH of about 5 to 9. So keep track of that, and be cautious with using any real acidic materials. So we'll talk a little bit more about that. So, the red wiggler reproductive cycle. Did any of you notice this little band right here on the worms as they're going around? This little band right there. You can see them. And many of those worms are of reproductive age, and I know when I packed them that some of them were in the process. So we might actually witness that today if you look through the little container. But that is your indicator that they are ready to reproduce, their reproductive age. That's called the, oh, I always mispronounce it. I think the L is silent. But that little band right there, it contains both eggs and sperm. They're actually hermaphrodites. Oh, I thought that was kind of cute. So they're going to actually connect at that band right there. So they're hermaphroditic, but they need each other to reproduce. So they're going to connect at that band, and then they're going to release these egg cells. And when these egg cells come out, that's their babies, and each of the mating pair will release those egg cells. So if you look through our material today, you're probably going to see some of these egg cells. Our worms are producing a lot of eggs right now. So each of the mating pair will release a cocoon, and it's the cocoons when they first come out are a little bit slimy, and they're not as yellow as those pictures when they first come out. They develop that yellow pigment over time. But they typically contain, and I've seen numbers anywhere from 2 to 11. But 2 to 7 seems like a pretty reasonable number of babies inside of each cocoon. The incubation period is anywhere from 30 to 75 days, depending on the conditions. And then once they hatch, those newly hatched worms will then themselves reach sexual maturity, where they have that band, and they're ready to reproduce between 45 and 150 days. So that's a sort of a longer period of time, but I think it has everything to do with the conditions they're living within. And then on average, you'll get 9 young per worm per week. So that's a pretty active reproduction rate. And then life expectancy is 4.5 to 5 years. Now, of course, if you
have a food, you're on welfare from us.
Yeah, exactly.
Right?
Yeah, so right? So these worms, really, when you start out with a pound, you can end up with a lot very quickly if your conditions are right for them. Okay, so we're going to talk about getting started and how to do it at home. And you want to start your vermicomposting system by selecting the appropriate container for your scale. So these are some of the factors to consider right away. We've already talked about temperature. We've talked about proper moisture. So the proper moisture, and then is like we talked about with the igloo, she drilled holes in it for good airflow and drainage. So your bin always wants to have a good drainage system for it. And then you want to have the right bedding and the right feedstock. So feedstock is the food. That's what you're feeding the worms. Yes, ma'am?
How do the worms not go through the holes you drilled in the bottom of the...
Yeah. Yep, so it depends on, let me see if I can...
They don't like light.
Okay, so this bin right here, this is just a simple design. It's been really good for some of the classrooms that are doing vermicomposting. And what it has is it's got this little screen in the bottom, and that's supposed to keep the worms from going through. It has drainage holes in the very bottom, on the bottom of that screen. So ideally the worms wouldn't get underneath it. And then the air that it has for ventilation is up near the top. So the air comes in through the top, and it's got another ventilation system on the very top. So yeah, you want to be able to contain your worms. I have a system at home that I actually made out of one of these old car top carriers, and I'll show you a picture later. But what I did is I drilled holes in the bottom of it, and then I lined it with really fine window screen. And window screen, whatever that mesh size is, they don't get through that. So somehow to contain them is a good idea.
You're talking about the underground
Mm-hmm.
area. How do you do that?
How do you build them underground? Well, you'd have to have them in some kind of container, or I guess maybe you wouldn't even need to have them in a container, but if you maybe dug a shallow hole, you know, maybe it could be 6 or 12 inches deep, but kind of wide, and then you could put your vermicomposting right in there. And if you're somewhere where you maybe get some frost, but you don't freeze 6 inches deep, if you stack over your bins, over your worms, if you stack on top of them some hay, then the ground itself will insulate the worms, and the hay on top will insulate them. That make sense? And then bedding we're going to get to, but that's what your worms are living in. So our bedding on Little St. Simon's, we actually use this shredded office paper. So I'm going to try to not make a mess in this classroom. But so bedding is typically in thermophilic composting. It's often the carbons that we're used to using, the wood chips or cardboard or leaf matter. It's usually the carbon source that you use as bedding. So first, what I advise people to do is think about what your feed source is, because that's what's going to keep your worms alive. And that's going to determine your scale. If you're a large-scale industry or a farm like ours, you're going to be looking to go pretty big. If you want to do vermicomposting just for your family or your church or your classroom, a bin that size is going to be fine. So the first thing to do is think about what are you going to feed your worms. And so this is a list of what to add. So you can add vegetable scraps. And I have here at the very top, chop it up if you can. I mean, I know people that actually have a special blender in their kitchen to chop up their worm food. I don't do that. I do chop up like a large watermelon. And that has to do with those microbes we were talking about. The less time it takes for those microbes to start breaking that food down, the quicker your worms can feed on the microbes. So there is some advantage to chopping it up. But of course, you know, we all do what we can. And you certainly can do this without chopping it up. It's just going to be a slower process. So vegetable scraps, food scraps, and I have there limit the citrus. That's because of the pH and the acidity. I put citrus in ours all the time, but I don't, it's a moderation thing. And if you were to do, you know, if you have citrus orchard, I would be really cautious about putting your entire orchard scraps into the vermicomposting. But you can use those pH meters to monitor your pH as well and learn to find what works for you. So you can put shredded paper, you can put torn up newspaper into your bin, and that's both a feed source and a bedding source. Eggshells are great. They provide a lot of calcium, and they also provide grit. The worms need some gritty material to help them digest, so eggshells are really great. You'll see in our material that we're passing around that our eggshells will break down. Once they've gone through the vermicomposting system, if they haven't gotten sifted out, then they'll go into the garden and they'll continue to break down over time. Coffee grounds are really great, tea bags, and then yard and farm waste. So, you know, if you're using any animal manures, what's on the not to add list is pet waste, of course. We don't ever compost pet waste. But animal manures are great. You know, rabbit manure, chicken manure, cow manure, horse manure, all those things are great feed sources for vermicomposting worms. So certainly anything organic is compostable. We know that from the lessons of nature. And our kitchen probably.
Why wouldn't you compost breads or pastas? They don't break down?
Well, no, they will break down. They're compostable because they're organic. They're going to cause critter issues and bug issues. Okay. So it's best when you're first starting to really just keep it simple. Okay. And if you're gardeners like we are, you probably have a reliable supply of food source for your worms. I will note that coffee grounds, most of the coffee facilities and Starbucks and those places hold their coffee grounds for gardeners. So if you're looking for a source, that could be a great place to check into. Yes, ma'am. What's that?
Why not use pet waste?
The pathogens in the cat and dog poop could be harmful. So it's good to just keep that separate.
Any farm animals?
But farm animal is fine. It's something different. I can't tell you more than the pathogens and what
It's
varieties
because they're
there are, but-
herbivores and not
Not gonna eat.
carnivores.
What's that?
It's because they're herbivores and not carnivores.
Oh, okay, so they have different bacteria. Okay. So I stay away from meats, dairies, oils, breads, pastas, diseased plants, because I'm not necessarily 100% sure that my hot composting that I do before I feed it to my worms is hot enough all the time. I don't put any diseased plants in my composting system. And then weeds, if you're certain that you have it hot enough, if you're pre-composting, great, compost them, that's great. But if you're not, if you're just doing a cold composting method like vermicompost, you probably want to skip the weeds.
Why?
Because the weed seeds won't burn off because the temperature never gets hot enough to distinguish that seed life.
So you get weeds.
So you can get weeds. Yeah, so the solution to that is to pre-compost first, and then let your worms finish the job. Okay, so determining your scale, worms eat, and you're gonna see this number all over the board in marketing information, but basically they are probably gonna eat about 25 to 35% of their body weight per day when they're feeding normally. So the ratio when you're starting a new bin is typically 2 to 1. So 2% or 2 parts worms to 1 part garbage. So for every 1.5 pounds of worms, you need 1 square foot of horizontal surface area. So that has to do with them being epigeic and that they live in the very top layers of the soil. And so a worm bin, compost bins are, any size. We've seen windrows at farms that are, probably 8 to 10 feet tall. You want a worm bin to not be very deep at all because they want to live at the very top of that soil surface. So when you're thinking about your system, you want to think about horizontal surface area rather than depth and vertical. So most home systems would start with about 1 pound of worms for 1/2 pound of food waste a week. So that system right there is perfect for that size.
So is a box like that shaped better than one like, the shoebox type that you can slide up under a bed, which is actually
No, I think a shoebox
the
longer.
plastic, yeah.
Yeah, I think longer and not as deep is really ideal. Now, what you're going to be doing in that kind of system, this system is designed, and these couple systems are going to sort of explain a few things too. But like this system here, the can of worms, the idea is that you have your initial layer that you start with, and you add your worms and your food, and then the worms will continue to move up and eat that next layer of food, and move up, and your finished material will be on the bottom. So if you don't have a lot of vertical space, this design is meant so that you start at the bottom, and you feed up and up and up, and when you get to the top, you stop, they finish, and then you start over. So a vertical system, you would actually be feeding kind of down the system rather than piling it up. And the worms will move over and find the food. But yeah, it's fine. And that way you can also then keep a really good sense of how much moisture there is in your bin if it's not too deep. And it can keep from getting compacted. Some of the paper materials or a lot of people use cardboard, shredded cardboard, and shredded newspapers. If you're using shredded newspapers, you want to take the time to tear them apart so that they're loftier and they don't get slick and stuck together, because that compacted material then can prevent airflow for the system. But these are just a couple simple home designs, and then these are a few of more larger scale. So this is actually a box that we have on Little St. Simon's Island, and it's a box design that came from this book, which I have a few copies to sell, if anybody's interested. I think this is a great startup book, Worms Eat My Garbage. And it gives a lot of biology and some of the science and some really good design ideas, and it's a good one. So whatever the selling price is, if anybody wants one, you can get one today.
How large are
Is
those bins there?
So those bins there are about 2.5 feet long and about 2.5 feet deep. And then about, I think they're maybe 18 inches wide. And that design is in there. You can also find the designs on the website.
How do you then get your, are you sifting the dirt out?
Yeah, we'll talk about
Okay,
that.
all right.
Yeah. What I like about the wood for the south you can see these boxes are actually from 2008, so they are falling apart. It's untreated plywood, I believe, that we started with, and it warps. But that's good here in the south because we need to have that moisture circulating through. Plastic down here, unless you can really control it and keep it inside during the heat of the summer, is maybe not going to be a good breathable material. So it might be better if you're going to do a larger system to use wood or concrete or some other holding containment so that you have better airflow and moisture.
I've seen people do the concrete blocks.
Yeah, and actually I think that's
And
in the
they
next
build that
picture.
up.
Oh, let's see. Well,
But I don't know if they put a barrier at the bottom. Do you know if they would put a barrier or?
They might, like there's one
Yeah,
design
like
right
that.
here with concrete blocks. You can see that one, and then there's another one right after it. So they've put, those guys have put some kind of,
Looks like an old ice chest.
oh, this is actually my car top
Oh, okay,
carrier
there you
I
go.
told you about. So that has the mesh lining on the bottom with drainage holes drilled into it. And then this one, it looks like they've put, now you want it to be porous. So you might not be best in wanting to just lay concrete down. That might not drain very rapidly, but it looks like they put some kind of gravel in it that would prevent the worms from crawling through, but it would drain. So you could also use landscape fabric or, you know, some kind of very, very fine mesh screening on the bottom of your bin. The concrete is actually really good in the south because it does breathe. And then this is a medium to large scale vermicomposting system. So if any of you heard of Bear Creek Worm Farm, they're out in Douglas. Really great man that runs that. And he sells his castings, so if you're looking for castings to buy, you can go there and buy a truckload. And you can see his operation. So he's the one I told you about that had the lights, and his field looks like a baseball field, and he's got shade cloths, so he's trying to protect them from some of the heat during the summer. And he also has mister systems set up, so they're automatically getting watered. But those are kind of some large-scale system ideas. And then, of course, windrow vermicomposting is also something that people do on a large scale. And then just note that those systems, that actually might be a missed picture, but a windrow for vermicomposting, if you were going to do a long pile, it would never be more than 3 feet tall, because you don't want all of that moisture and temperature to get contained in the middle of the system like you do in hot composting. But then these are some inside design systems that people are using. These are called continual flow vermicomposting systems. And they're actually adding new feed all the way down the line, so sort of like that horizontal box we talked about. And then the finished material ends up at the end. So these are just a couple ideas of people that are doing. There was a gentleman at the conference I just went to that's, I think he's collecting about the waste from about 10 commercial hog farms in New York and vermicomposting it with similar systems to this. So that you can be as low-tech or as technical as you want to get. You know, in a box like this, I think those sold for $30 or $40. You can build a wooden box for however much the wood costs you. You can do it in a Rubbermaid container. You know, that box didn't cost us very much. I think a can of worms or some of these designs like those, I think you maybe find them in the range of $125, something like that.
Would
So,
treated wood hurt them?
yeah, I wouldn't use treated wood. I would avoid that. It wouldn't be a bad
Would it
idea
affect the soil too?
to, what's that?
Would it affect the soil too?
Yeah,
Would
well,
it be
and
organic
my
anymore?
project is certified organic,
Yeah.
so I couldn't use treated wood anyways. What I would recommend is treated wood for the base. If you want to use a box or something like the design that I have, it's a really good idea to put it up on a base, so it's standing on legs. Oh, I'm going the wrong way. Because you're going to end up with ant problems. And if it's up on legs, then you can maybe control around it. And you are going to likely get some moisture flow off. So it's a good idea to have it on metal posts or some kind of solid base. But then anything that's going to touch the surface of the worms or the castings needs to be untreated material.
When you bury the food in the box, do you bury it all the way or do you sprinkle it along the top?
Yeah, we'll talk about that.
Okay.
But you're gonna add it as you add to. You're gonna add the bedding as you add the food waste. So we'll get to that. But talking about the containers again, untreated wood, plastic with vent holes, or wood. Those wood boxes that I have, we've drilled holes on the bottom, so they do have additional drainage other than just where the seeping occurs. Concrete blocks. So you want to use clean and pure water for your compost, or if you're going to make compost tea. If you have city water, it's not so terrible for watering your worm bins to use your city water, but if you're going to make compost tea, what you might want to do, you can only use non-chlorinated water. So you just let that water evaporate for 24 hours and the chlorine will dissipate. Yes?
So well water's fine?
Well water's great. So you have your container, you have your bedding, so you want to have a good bulking potential. And you want to have a low protein, nitrogen ratio, and ideal moisture content is like 70 to 80% in the beds. And so in your worm bin, what you can do is you can buy a fancy moisture reader, and if you're going to get into this professionally, it's probably a good tool to learn. When you're starting out though, you're going to just want to touch and feel and get to know your system, put your hands in there. Typically what you're going to find is, like in regular compost, if you squeeze a handful and water rushes out, it's too wet. Or if your bedding material is drying out, your worms are trying to leave, it's too dry. So like anything else, this is all about trial and error, because the way that it works for me is going to be different from you, because we're not eating the same foods or using the same bedding materials. So it's really just best to really pay attention. You don't want to start a bin and then walk away for a month or two and expect that everything's going to be fine. You want to be checking on it, every couple days at least, and make sure that things are happy. Yes, ma'am?
So we have a pound of worms and half a pound of food. How much bedding?
We're going to get to that
Okay.
about the bedding. Yeah, and because it's going to depend on what material you're using. If you're using wood chips or spent grain, it's going to be different than maybe paper. So that's going to be something that you're going to determine. But we'll talk about some ratios just to get your system started.
Okay.
Okay, so we talked about beddings, and then we talked about the worms. So the other thing you're going to want when you're getting your system started is a good handful of compost to inoculate the system with beneficial organisms. Because we talked about it's the microbes, the bacteria and fungus that are making composting happen, and then the worms feed on that. So if you have a good healthy garden, you might be able to just throw some of that in, or maybe get a good quality compost. And just throw a handful in there and make sure that those microbes are good and popular. Okay, so we'll move it quickly here. Then the other thing we talked about was the grit. The worms actually need a little bit of grit in their system for digestion. So I have so many eggshells in my system that I don't really worry about it too much. But a lot of people will add things like green sand or rock dust. We've heard a little bit today about azomite. That could be a potentially good mineral to add that could be beneficial to your worms.
Do you break up your eggshells?
I don't.
Smash them up?
Yeah, a lot of people do like that type of that. But I don't.
Can you use the grit that you put in a bird cage?
What is that made of?
Granite.
It's what?
Granite.
Granite. Oh yeah, that should be fine. Yeah, as long as it's real fine. Is it real fine?
Yeah, well, no, not real fine, no.
Like sand.
Like sand. Sand would be fine. Yeah, if it's like sand, that'd be fine. Okay, so then the bedding options we talked about, cardboard, wood and paper pulp, compost, animal manures. Coir, if you haven't heard of that yet, it's an alternative to peat moss. And peat moss can be used in your bins. It can be acidic, so you want to watch the pH levels of that, but it's fine as a good bedding source for a small system like that. Coir is an alternative to peat because it's a renewable resource. It's actually the husks of coconuts, that outside fiber. And what's neat about that is you can buy a small block, put it in your wheelbarrow, you add water, and it's like boom, and it explodes, and you have 10 times as much as that little block you started with. So it's a good alternative for bedding mixes and stuff like that. A lot of people really like it. But it must, whatever you're using, it must have the ability to retain moisture, must remain porous and not packed tightly like we talked about. And then it may or may not provide food source for your worms. It will get decomposed over time.
So no soil? No garden soil or anything like
Other
that?
than your first sort of
Compost.
inoculation, no, you don't need to add more soil. Okay, so we saw these pictures of the larger scale systems. And then a couple methods of control, just thinking about these being non-native species. So this is Jack Brantley's farm with the lights around the outside of his farm. And then this system here is just an example of a mid-size contained vermicomposting system. So it's getting really a good potential for industries and institutions like prisons to be doing vermicomposting as a sustainable way to manage the waste and also to generate income because they have this black gold product to sell. So it's a really great opportunity for our industries, and a lot of people are starting to use these sorts of machines, which I think a system like that can cost, $5,000. But it's becoming more and more popular. So starting your new system, once you've decided what container you're going to use, you want to locate it in the shade, certainly if we're in the south here. And the shade is fine year-round for us here. You don't need to move it out in the sun during the wintertime. It's fine. You're going to start with 6-inch layer of bedding, whatever your bedding is. So you put your 6-inch layer down, and what you do, I don't want to make a mess in the classroom, but what I would do with either newspaper or my shredded office paper is I would fill up my bucket of water, and then I would dip the office paper in it and then squeeze it out. So it's moist but not dripping wet. Then put a 6-inch layer in the bottom of my box, whatever I'm using, and then add your worms. And it depends on, certainly if you've had your worms shipped to you, all that vibration and movement sort of bothers them. And so it's nice to just add them into the system and just let them sort of reacclimate. And then in a few days, start adding food to it. And so you add your worms, allow them to settle, and then you add a 1-inch layer of food waste on top of that bedding. And then on top of that, you cover it with more bedding. Shredded office paper, cardboard, whatever you're using. And then we put in here cloth. You could use cloth or burlap, something to cover the top of your system if you don't have a lid on it. Again, because they don't like light. And also for predators. You want to keep it covered in some way. Yes?
Are you wetting the paper every time you add it?
Yes. Not sopping wet, but moist, so you're helping with moisture control in your bed. And then I certainly don't always wait for the food to be eaten before I add more, but it is advisable if you can. If you have a system that works and it works for you. They only eat, they can, I've been told, be picky eaters, and so they'll sometimes be slow in breaking down the things they don't like as much. So it's one suggestion, but I certainly don't do it
So
every
you
time.
just lift the top layer of shredding to see that the food's been eaten?
You layer it. So you have your first bedding down,
Right.
initial bedding, add your worms, they go down in that bedding,
Right.
then you add the food.
Right.
They come up and eat that food, and on top of that food you have another layer of bedding.
Not as
They
thick
eat all
though,
of that.
The
What's
top
that?
layer isn't as thick, is it?
Not as thick as 6 inches. No, but you want to cover it significantly for flies and things like that. So maybe your top layer is, 3 or 4 inches, depending on how much food you're adding. But enough to cover it completely, so you
So
can't
you'll
see
know
any
they're
food
done
waste.
when they've eaten that top layer of bedding then.
Yep, and then you're going to add more food and more bedding and more food and more bedding. Okay, so maintenance. You want to be sure to be watering your bin, and the best is frequent light applications. And if you have a misting system or a soaker hose that you could potentially use in your bin, that'd be really great. The idea is to provide them with enough moisture but not flush them out. And so sometimes when your water is rushing out of the box, then you've overwatered it. And if you have a container like this plastic bin, that maybe doesn't have as good drainage as wood, you want to be really cautious about not putting too much water in at one time, because it'll pool up and become a problem. Then you want to monitor the temperature, like we said, ideally around 65, 75 degrees is good. I have seen my worms, and I've checked the temperature in August, and it's been 95 in there, and they're okay. They're not perishing, but they're not reproducing. And then when you see worms on the sides or on your lid or clumped together in the corners, that's an indication they're not happy. So you want to check your moisture and your temperature and your food source and find out if there's some predators in there that are disturbing them. But those are signs that things aren't going well. You want your bedding to stay fluffy, your pH again to be between 5 and 9. Your earthworms should have a moist, glistening skin. And then you want to watch for the abundant cocoons. That's a really good sign that things are going well because they're making babies and they feel good about their habitats. And then your bin should smell like a forest. It should smell good. If it doesn't smell good, you probably know that means the bin's anaerobic, and that means the stinkiness, something's gone wrong in the composting process and food is rotty. Okay, so troubleshooting. Here's your problem signs. Your worms are escaping. And that happens. And you might open up your bin and they're crawling out the sides. And I've had worms move from one bin to another bin overnight because there's been a problem. So that's your first sign that something's wrong. Fruit fly swarming means you need to bury your food better. I do, and all of us that I know that do this here in the South end up with the soldier flies, the larvae. And it seems to be real common at certain times of the year. A lot of people are looking at soldier fly larvae, which is a liquid casting, or poop, or pee, or whatever it is. They're looking at it as a fertilizer source, actually, for agriculture. So it's not a negative thing, it just can be kind of gross. I don't try to manage mine in any way. I do try to bury my food so that, because I'm in a public facility, I don't want fruit flies all over the place. So I try to keep it well covered. Okay, and then if your liquid is dripping out the bottom, that could be too wet. The worms could suffocate. If your material's too dry, it could attract ants and your worms could perish. And then red mites have been a problem. I haven't had any problems with red mites, but I know vermicomposters in Florida that have. And that can be a problem. They can actually be parasitic to the worms. That, I guess, I've read is a sign of your system is too acidic for red mites. I've had the white mites and other mites show up, and that's a natural part of the composting process. So leachate is a material that you might hear of. It's the liquid that comes out. And some of those systems, like that one on legs that was like a tray design, they actually have little spigots on them to collect that moisture. I put that up there because it's become a bit of a question in the industry whether or not we should use that leachate. All I can say really, to be certain, the best choice that you have is to make a tea out of your castings rather than using that liquid. The concern with that liquid is if you're doing any kind of animal composting and you're collecting the liquid that comes out after you water, it hasn't been fully composted, so it hasn't gone through the worm's digestive tract, which will process the pathogens. So it could just be flushing E. coli or something else harmful off of your vermicomposting, material and into your bucket. So if you're just doing vegetable waste from your own home, it's probably okay to use the leachate. One important thing though, through Ms. Herman's talk, he said this morning that anaerobic microbes, which is the microbes that can live in soil without oxygen or water without oxygen, can actually have harmful plant toxins in them. So be cautious with it. I use it sometimes on my citrus trees, but I don't ever put it on young seedlings or plants. So that's just a note on that, because a lot of people ask about using that material. So this is what else might live in your bin. Pill bugs, springtails, mites. I actually don't know if that's a picture of a millipede or a centipede. But millipedes, if you can tell the difference, they're really beneficial in your box. Centipedes are actually parasites, and they'll actually cause harm to the worms. So if you can learn the difference, that might be good. I think I have both in my bin. My worms aren't trying to escape, but just a note. And then of course, like I should have in this picture, there's mites that are normal part of the system, but it's the red mites that can cause harm. And I actually had a friend down in Florida who told me that he opened his bin one day and he had red mites just covering the whole top of his system. He took actually a torch and just torched the top of his bin. All the worms are down beneath, and he just fried them, and it worked. The other control, if you're concerned about the fruit fly larvae, I've had a friend who told me that he soaked a piece of bread in milk and put that in his bin, and all the larvae went to it, and then he just pulled it out, and that worked for him. Ants are going to be a problem, so potential pests and predators. For our project, we have armadillo problems. I don't know if y'all have that. They're not trying to feed on the worms, but they would love to get to that bacteria and fungus and everything else living in there. What's that? Moles and bowls, yep. So you want to have some kind of hardware cloth or something around your bin to keep them out. Raccoons are a problem for me because sometimes I haven't buried my food well enough, and then they'll get in there trying to get to that rotting food. Birds are a problem for me.
I've used, or what I'm using right now, we had extra siding left from a project, and I just put that down in the ground.
Oh, good.
So some of it's still sticking up, and then I've used old pallets for the sides, and that's kept the moles out of my compost.
Oh, nice. Okay.
I don't know,
So
I
it's a
guess they get it,
solid
yeah.
side of the
Yeah.
plastic or
Yeah, it's
something?
just half up and half, yeah.
Okay. Good. All right, so ants. Ants you can try to control if you have your system, if it's a small box like this and you have it on a table or you built a frame for it, you can put mineral oil in coffee canisters and stand your structure into that, and that'll help the ants from getting out. I've seen people build moats around their systems, and this comes with this tray, and you actually place this on top of this tray and then fill this up with water. And that's supposed to keep the ants from getting into your system. I've heard, I think it's a borax mix, if you put that around. Water, sugar, and a teaspoon of borax. If you put that around the outside of your bin, that can help control the ants. The problems with ants that I've had are carpenter ants. I've got fire ants and probably many, many more I don't know how to identify. But the carpenter ants seem to be the ones that make my worms want to leave. The other ones seem to be coexisting from what I can tell. And then these types of beetles, I don't know how to say them or recognize them, but if any of you do, I have beetles in my boxes that don't seem to be causing harm, but I just read that, so I thought I wanted to share it. So using your castings, you can make it into a potting mix, and I have a recipe at the end of the presentation if anybody wants that. Side dress your plants is really great. You can use it when setting out transplants. Like I said, even just putting like a quarter cup or even a third of a cup into each hole as you set out your transplants can be hugely beneficial. So what's great about this black gold and why it's so valuable is that its beneficials can be exponentially used when you make it into a tea, or even just a small quantity of it can be useful in setting out transplants. So raised bed gardening, which is what I do, and then seed soaking for germination. It can be really beneficial, and there's been a lot of research on that. Even just a 5% solution of castings to unchlorinated water, soak your seeds, and not for very long, even just for a couple hours, and then plant them out. They've been seeing really good results for germination. And then compost teas, which is what I use a lot of mine for. So harvesting, that can be a real problem if you have a large amount of material. So what a lot of people will do in just a home system is they'll stop feeding their system when it's maybe 3/4 of the way full, and they'll stop feeding the worms completely. They'll finish every bit of organic matter, then push it all to one side and add new feed to the other side, and they'll move over. And then you take that finished material out. You probably have to separate out some worms, but for the most part, they've moved. What I do on Little St. Simon's is I actually have these screens, these window screens, and I'll stop feeding my boxes, and then I'll put those window screens down, add new food, and they'll come up through the screens. Then I just pick them up and move them over to the new bin. That works really well. This is also, I think they call it the volcano method. Knowing that the worms don't like the light, you build little piles of the material, the finished material, and they move to the bottom. Then you scoop off the top, build a new pile, then move to the bottom, scoop off the top. So those are all the really labor-intensive, low-tech methods. And then this is just a little screen system that I have to sift out all the stuff. You're going to end up with chunks of whatever that hasn't really been composted well, like maybe bark or little pieces of plant material, or trash. I get a lot of trash in mine because we're a commercial facility. So you want to sift all that out. So I think I have a 1/4-inch material in there that I'm using to sift, and that looks really great, and that's how I look at that finished material I showed you. But the commercial guys use this. This is actually called a trommel, and you put your castings in one side and you turn it on, and it can process thousands of pounds at a time, and the worms fall out one chute, and the stuff that needs to be recomposted goes to another chute, and the stuff that needs to go, that can be used goes out the end. So we're in the process at Little St. Simon's of building kind of a homemade design that I got blueprints for. So if anybody's interested in that, see me afterwards and I can connect with you for that. So I know that it's really labor intensive to separate out all the worms in the process. So any tools that you can find will be helpful. This is a picture of some cover crops that I was growing in the beach sand with compost tea fertilizers. And I saw this clover shoot up and flower after my tea fertilization. And this was when I first started the project, I think our organic matter level was like 0.03% or something, like nothing, beach sand. And I planted out that cover crop just to see what it would do without no additional fertilizers, and the teas were really making a difference for them. So compost teas, which is basically taking your castings, you put it into some kind of containment bag where the castings aren't going to fall out. I use actually these little paint strainer bags, or sometimes I just use those little ladies' nylons You can buy these bags online too, but the ladies' nylons work great too. And then you add the material into it, and then what you do is you take that compost, and a lot of people are getting into compost teas. It's becoming really popular, and you can find a lot of information online about different recipes to use. I go really simple. I'll add in, for me, I put about 5 to 6 cups of castings in a bucket, a 5-gallon bucket of water. So I have the recipe for tea as well at the end of the presentation that I can give you. But basically what you're doing is you're leaching out a lot of the nutrients and micronutrients in the soil, and then you're also populating the bacteria, all those beneficial organisms that help our plants feed on the nutrition of the minerals in the soil and help our plants be better protected from disease. You're populating your soils with that. So if you're working with a soil that's either been degraded or is needing some structure and building, it's great to use a small amount of castings to inoculate your soil. And then you add oxygen, and that's really important to add oxygen because you want the good microbes to populate instead of the bad anaerobic ones. So I just use this little cheapy little fish tank aerator, put it in my bucket, and then, what's that? Oh, little worm. And then, thank you. Here.
Still alive?
Can you put him in here?
Yeah, he's slimy.
Put him in there. And then you let it aerate and percolate for about 24 hours, and then you can apply it. And the great thing about compost teas is that they're not super high in nitrogen, so they're not going to burn your plants. And so you can put it on full strength, or you can dilute it to whatever rate you want to use. What I do actually is just use one of these cheap fertigators, I think they're called. Put my tea in here, my garden hose goes on one end, and I spray it out on my whole garden. You know, you can use a watering pail. And I've seen every different ratio from like 50% casting tea to 50% water is a good ratio to use. The only caution I would have is if you're using a sugar source to make your tea, which I use sometimes molasses, and the reason for the sugar source is to feed that bacteria, so you're even further populating the beneficial organisms. You can use some kind of sugar source or carbohydrate, and that molasses can actually cause the new leaves of like your lettuce seedlings to stick together. So that's the only sort of caution I have. So it also can really help increase the tolerance of stressful conditions, both drought and overwatering. It's, you're going to put it on in the evening or early morning, and it's going to protect the leaves, so it's a little bit of a natural insecticide, prevents fungus, and provides an instant fertility boost without burning. So this is a compost tea recipe. I can go back to it if somebody wants the recipe. This is a soil mix recipe if somebody wants that. And then this is just a little bit of the research that's been done. So this is research that's been done by UGA for that Bear Creek worm farm. So you can see these are the vermicompost castings, tomatoes grown. The middle one, I believe, is red Georgia clay, and then the far one over is just your basic potting soil mix, like Metro Mix. So you can see the difference in their studies for the tomato plants of vermicompost. And then University of Hawaii's research, they're finding all the disease suppression really effective for some of those different crop varieties. And then they're demonstrating control effects for some of the common pest issues that we have: aphids, mites, caterpillars, cucumber beetles, hornworms, mealybugs. Now I will say this, it's really best used as a preventative. It's healthy maintenance. And that's what we all sort of say in organic agriculture, is we want to focus on healthy soil, and plants that can handle some pest pressures and be resilient are a good result of healthy soil. So it's not going to solve your problem if you already have a problem, but it's going to help prevent a problem in the future. But University of Hawaii found that in their research, these pests that they were studying, lost their mojo. And after eating plants grown in vermicompost, they stopped breathing. So, and then again, like I said before, there's been a lot of good research on vermicompost. I'm sorry I went over. But thank you all so much. Here's some more resources. There's some more books on